So now that we have learned some of the gas laws that are just comparing two variables, let's explore what happens when we put those together. So first we had Boyle's law, and Boyle's law related pressure and volume. And pressure and volume were inversely related. So when pressure increases, that must mean that volume decreased. Then we had Charles' law, which related volume and temperature. And what Charles' law says is that when volume and temperature are compared, it is a direct relationship. So if we increase temperature, we're increasing the speed of the particles, and therefore we would need an increase in volume. And last but not least, we compared pressure and temperature, which stated that when we had a constant volume and we increased the speed of the particles or increase the temperature, we would then increase the number of collisions with the walls of the container, and therefore pressure would increase. So now let's put all of these together. And when we do that, we get PV over T. Because in Boyle's law, remember we learned that pressure and volume were inversely related, but then volume and temperature and pressure and temperature are directly related, and therefore that's what the combined gas law looks like. Whenever P, V, and T are equal to a constant, and then you change the conditions and it's equal to the same constant, we can then put those together into the combined gas law. So the combined gas law is P1 V1 over T1 equals P2 V2 over T2. So what's important, just like our previous gas laws, is that all the units must match. So it doesn't matter what your pressure's in as long as they're the same unit. Same for volume, but temperature must be in Kelvin always. So let's take a look at a problem. So here we have a gas occupying a volume 7.84 centimeters cubed at 71.8 kilopascals and 25 degrees Celsius. So let's find what the volume would be if we change the conditions to STP. So what's given to us? A volume, a pressure, a temperature. And let's automatically convert that 25 degrees Celsius to 298 Kelvin. Now at STP, we're looking for the volume. Pressure at STP is 1 atmosphere, but because the original pressure was given to me in kPa, I'm going to record that as 101.325 kPa, because remember that's equal to 1 atmosphere. And temperature at STP is 0 degrees Celsius or 273 Kelvin. So I'm going to use the combined gas law because I have P, V, and T. You can see here that my pressure is going up, my temperature is going down, and therefore perhaps my volume's going down. Both of those would indicate a decrease in volume. So there's the combined gas law. And I went ahead and did my cross multiplying here, right? So I took my pressure and volume on the top and multiplied it times the second temperature on the bottom. I'm going to set that equal to P2 V2 over T1. So just some cross multiplying before I plug in the numbers. So there are my values. That's going to be equal to that. So then to solve for V2, I'm just going to divide both sides, and my new volume is 5.09 centimeters cubed. I was like, let's make sure that this makes sense. So my pressure, right, went up. That would indicate a decrease in volume. My temperature went down. That indicated a decrease in volume. So this answer makes perfect sense. So let's review the gas laws that we've learned so far. We've learned Boyle's law, which relates pressure and volume, which means that we're holding moles and temperature constant. Charles is volume and temperature. Then we have pressure and temperature, and then we can combine them all together for the combined gas law. So I like to just use the combined gas law because it has all three of those together, and then you don't have to memorize each one individually. Okay, Let's take a look at Avogadro's law. So Avogadro's law is going to be our last law that is just going to relate two variables at a time. And if you remember Avogadro, so from whenever we talked about moles, this was the actual work of Avogadro. Remember, he didn't actually discover the number 6.022 times 10 to the 23rd particles is 1 mole. The work he did had to do with gases. So this was actually Avogadro's work. And what he found was that the volume of a gas increases or reduces as the number of moles are being increased or decreased. And what he found was this was directly proportional, which I think makes perfect sense. You have more gas, it's going to take up more space. So what he discovered was that equal volumes of gases contained equal number of moles. He held temperature and pressure constant. Now, what is revolutionary about this is that it is true for any gas. So no matter what gas you have, if you are having a constant temperature and pressure, it will occupy the same amount of space. And for moles, we use the variable N. So what Avogadro found was that at the initial volume divided by the initial number of moles, that equaled a constant. And we know that then we can set that V1 over N1 is equal to V2 over N2. So this is another direct relationship. But again, what I find completely, I don't know, mind-boggling is that it doesn't matter what gas it is. If you have a mole of oxygen at a certain temperature and pressure, it's going to occupy the same volume as a mole of carbon dioxide. So that's Avogadro's law.